everybody. Hi, folks.
Hey, good morning.
Good morning. So agenda-wise, I think perhaps Ahmad and Kash, you guys might have some follow-ups, I think, from some of the prior discussions. And then the other thing that I was going to sort of mention, which hopefully won't be, I guess it'll be a surprise, but hopefully not a bad one. So Kevin, you guys had mentioned about some of these UMI things, the universal memory interface things that you were looking at, sort of in the workshop last week. So I thought it might be actually interesting to sort of raise some of the ideas and sort of points and discussions here. And Boppy and I were talking a little bit, and we had some thoughts and ideas we wanted to share. And yeah, if you're open for it, that'd be great.
Yeah, I think Boppy thought that we would talk about it next week, but I am happy to sort of extend. I haven't prepared anything, but we can.
Yeah, no, it's totally fine. Yeah, we can just talk things through. And yeah, I mean, Boppy and I were talking last night, and part of the thinking was, we wanted to give you some sort of early feedback and thoughts and things like that, so that perhaps even assuming it looks sort of reasonable to everybody, and particularly obviously to you, perhaps even we can incorporate that in the talk you do next week too.
Right.
Great.
Yeah,
Okay.
I also thought it was very interesting seeing that presentation, right? So I would certainly like to learn more. So Alad, just quickly on the unfortunately, we didn't have time to draw out some of the different options. I think we're definitely on the wavelength of trying to have a couple of options depending on what the customer wants. So we'll kind of draw those out for next week. So
Sure.
If we could have like 10, 15 minutes next week, and then then Kevin can do more next week, but certainly would like to have that UMI discussion. Kevin, any more information you can share and Alad your thoughts, because I think it is I'm not sure I understood everything. I'm a bit slow, but because it was the first time I'd seen some slides on it, but I certainly thought it had a lot of potential merit. So that was just my comment.
Yeah, no, sounds good. Cool. All right. So now that we've sprung this on you a whole, 2 minutes ago or whatever, Kevin, did you want to sort of give a quick intro? If you happen to have slides or whatever, that's great. If not, if you wanted to do, my interpretation of it, I'm happy to do that too.
Yes, indeed. So I see Boppy just joined. You're online, Boppy, right?
Yeah, sorry, yeah, so I sort of discussed this with Elad and Ramin as well. I think starting today is great, and I also think it's worth sort of presenting to the Friday group at a point whenever you're ready. Either
kind of what I thought you had asked Ramin to do.
Yeah.
We can talk about it today, and
so I think the main intent, so in my head, the work obviously gets done here, whatever we want to do. The main intent in my to sort of spring it to a different audience. I don't even say the larger audience, is to sort of announce to the world saying, hey, we're going to work on this. If you feel like joining in, come on into the Wednesday meetings. That's the main objective.
Okay. As Elad said, it'd be good to get some sort of like initial impressions on what that means or how that works, and what some of the how we might operationally do that. But he was saying we could just have a rough sort of open discussion today and freewheeling sort of feedback. Let's see. If we want to,
you already heard what Kash said, that it has no merit now. It has potential merit in the future.
Well, I
I'm
said
sorry.
I didn't understand everything, but it seemed like it had a lot of merit. So don't change my don't go negative on me, Boppy. Come on, you got to stay.
You're the one who said potential.
You guys are always reserving your negativity for me, so don't take it away from me.
You're the one who said potential merit, not me. Sorry, Kevin. It was just laying there and I couldn't resist. I'm sorry.
Understood.
Eh,
So, do we have other topics today, or do we want to sort of launch into that?
Yeah,
Well,
no,
there are two.
sounds like we should launch in. Yeah, or did you have something
Yeah.
else, Poppy? Or yeah.
Yeah, I did want to talk about the 5 workshop as well, since Kevin was nice enough to sponsor it and everything, and I didn't want to spend about 5 minutes or 10 minutes just going seeing whether any who oh no except Kevin, Majid, you and I, Ahmad didn't attend, Kash didn't attend. Okay, never mind. All right. I was going to have a quick discussion on what we thought of it. Any first order impressions too. Those are the two things in my mind. The whatever Kevin's going to do, and then a quick discussion about the workshop.
Okay.
Well-
I mean, up to you. Yeah, please go ahead.
No, I think we'll roll with Kevin. Then after he's done, we'll do that. I'm all good. Sorry,
Gonna roll with me first? Okay, well, let me
if you
look
don't mind.
a couple of things first.
And the experience center, it was awesome.
What's
Gosh, did you
that?
check it out?
Yes, I did get there, and I did think it was very well done. I was a bit confused initially because they were all merged into one big experience center. So I was, I was my own confused self, but yeah, I thought it was very good, and I actually got to meet Kevin at his and Sean at the Allianz booth as well, or demo center. So it was good, and I thought the whole thing was well done. Yeah, absolutely.
All right, man. The only acceptable answer is that I had to find out where you live.
Yeah, I know.
And I agree.
Yeah,
Or I had asked you, Boppy, about slides from the workshop for attendees and all that kind of stuff. Are you gathering material? What's gonna happen with that?
I do. I have to send out a note to all the speakers, getting their permission, and sort of I'm sort of just still recovering. Then I had to write a couple of other documents before early in the week, so now I'm going to follow up on that this week.
but aren't the slides anyways, since videos would be available, they're public already, no?
They are, but I kind of like to cross my
Okay.
T's on that. Just
Right.
get everybody's okay.
No, I think, at least on my side also, it was great. And in fact, the diversity is a good thing, because then you could see this in a bigger context. And no, it was fantastic job, and yeah, for
Yeah.
us, yeah.
Yeah, Bob, I
And-
guess as I told you, it worked out much better than I expected it would. So
Oh man, do I have the picture for you? Hang on, I'll show you. Hang on.
So depending on how low Elad's expectations were, you could take that positively or negatively.
Yeah,
That, right?
exactly. So I've got something for him.
No,
Yeah.
it was actually, to be frank, my expectations were actually fairly low, but they were vastly exceeded. So, so it is a positive statement.
Here, look at well, Kevin's wondering what kind of madhouse he's locked himself into, but such is life. Here, Elad, this is for you.
There you go.
Did you see it?
That's a good one. I like that. So is that copyrighted? Can we use
No,
it?
yeah, I'll send it to you. I'll put the link. It's from a tweet.
There's a lot of truth in that statement,
I'll put it in the chat window. Hang on. We all of this is being recorded. I just
Yeah.
you guys know all this.
I have a
Kevin, the
Russian
floor is
friend.
yours, man.
I was going to say I have a Russian friend, and he really is. We joke about it, but he's always so friggin' negative.
That's the first thing I did.
crazy.
I shared it with my Polish friend. That's literally the first thing I did.
Okay, should I try to share something?
Yeah,
By all
please.
means.
Let's see if I can do this.
There you go, guys. It's in the chat window.
All right. Let's see if I can see what I'm sharing. Ugh. Hello, can you see my screen?
Yep.
I cannot. What did I do? Again.
We can see it again.
Oh, and for some reason I can't see what I'm sharing, which makes it really hard to
Oh, you're
Do
probably
you
on
want to send one
extended
of us,
desktop.
or do you want to send
yeah,
one
I
of
got
us
a
the
remote
slides?
desktop and I'm just trying to get everything all set up. All right.
I guess actually,
Anyway,
if
this
it's
is
from the workshop, Boppy might have the slides. You can just share it, and then you can see it.
this is actually from the talk he did on Thursday, but it's the same thing. So
Yep.
the concept that Ramin was promoting when he talks about UMI is something that's universal, where it could connect to different types of memories. The same ASIC could have a high capacity or a high bandwidth kind of operation, depending upon how you want to build different SKUs out of your products. That's the basic idea. The idea when we initially pitched this with UCIe was, how can you use die-to-die interfaces to do this? It turns out that fixed unidirectional links don't work very well. You just can't get enough. This caption says that bidirectional signaling doubles the bandwidth, but what it really means is for a fixed number of traces. This is showing it really takes 2 N traces to get the same bandwidth you do out of N traces if you can do bidirectional signaling. And so what we're looking at when we talk about with this PHY group is really at this level of what can we do differently PHY-wise. Make sense as a start?
Yeah, at a high level, yeah. I mean, I guess whenever you're ready for some of the thoughts and feedback, we can dive into it. But
Well, I want
the first start, yes.
I want to give one more point, which is this year. This is a slide that those were means. This is mine that I was preparing for this meeting, except I thought it was next week. So I'm not.
Yeah,
very-
I'm okay with
No
doing
worries.
that way too, Kevin.
So what are we talking about with bidirectional? So fixed unidirectional, you can see on the far left, it is what UCIe is. And typically under a bump, they just have either a transmitter or a receiver. Configurable bidirectional is what is supported by Bo, and you have bidirectional PHY, but it's configured at initialization to be transmit or receive. Last week or a couple weeks ago, when Eurochip was talking about their solution, they were talking about something that could be configured in different ways with the bidirectionality, but maybe half transmit, half receive or something. And the clocking on that becomes pretty interesting. What we're talking about is this third column, which is dynamic bidirectional, which is how all memory PHYs work. And then the fourth column, which is simultaneous bidirectional, is something that Elion does, but it doesn't have anything to do with this discussion. It requires echo cancellation, all kinds of complicated stuff. We're not talking about that. What we're talking about what I want to talk about, or what the idea for UMI is to take a die-to-die spec, and our preference, as we talked about with Boppy, is to take it through Bo. Because Bo already supports configurable bidirectional, and we want to see if we can update the spec to support dynamic bidirectional. So I know this may not be like an industry standard terminology, but this the terminology I'm using, and that's what I wanted to communicate with this slide, so that when we're talking about it, we're on the same page. Any questions about this slide? Does it make sense?
That's a great slide, by the way. I think that's helpful because people get very confused. So that's really good.
They do. They'll constantly get confused about simultaneous bidirectional, which is can give really awesome beachfront bandwidth metrics, but it's complex, and it obviously doesn't work. It's not interoperable, where dynamic bidirectional PHYs are everywhere, and everybody makes them, and Elad and I and most of the people on this call have probably made lots of them. So there's nothing particularly unique about them. Once you have a configurable bidirectional, you could do a dynamic bidirectional. It just depends on turnaround times and the control to do the turnaround. But conceptually, I would say you're 80% or 90% of the way there. So I think building upon Bo would be a really good way to go. And that's what I and Ramin hope to do.
Papi, you got to patent that building on Bo is the way to go.
Building
Right?
on Bo is the way to go.
So I think it's a great line.
We can get t-shirts made up and everything.
Yeah, no,
Building
yeah,
on-
it will piss off the UCI crowd. So I think it's a
of
great
course.
thing. Yeah, you got
And-
a twofer.
No, now we're friends with everybody, man. We had 4 UCI talks in our session, in our ODSA session.
Really,
So.
unfortunately,
By the way, good job, Bappy, on that.
See, Anila didn't believe me.
Except they left very quickly.
Yeah.
We could have had some interesting discussion given time.
Boppy
Yeah,
is
baby
friends
steps.
with everybody, but not everybody's friends with Boppy.
Story of my life, man. Hey, Kevin.
Oh, yeah. So what I asked a couple of questions in our last meeting, which is 2-3 weeks back, about the proposal, from your trip and how it gets adopted. So obviously, we are not envisioning a mandatory, compliance type thing. It would be, I think the way you described it, Boppy or Elad, I can't remember who, is things could be done as optional addendums to the spec, so that using a Bo bump map, one could choose to support this, but it's like an optional mode, not a required mode. I'm not sure if I'm using the right nomenclature, but that
No, that's fine. Yeah.
is that the right kind of path?
Yeah, I mean, yeah. Please go ahead.
Unlike the discussion we had with your chip, I'm personally not a fan of trying to send signals upstream against a clock without any time reference. So I'm envisioning, 2 PHYs next to each other, but instead of one has a transmit clock, one has a receive clock, and a bunch of signals can be bidirectional that use either the transmit clock when they're transmitting or receive clock when they're receiving, so that timing references follow the spec naturally. And of course, all memory PHYs have some fixed unidirectional as well as bidirectional signals, so they need those timing references anyways. So if you consider how you would build this with 2 slices next to each other, it's not a far-fetched extension of Bo, in my opinion.
Yeah, no, I think that does make sense. I guess whenever we're ready to sort of get into the
Yeah,
sort of-
I'm done with my highly detailed presentation, since that was prepared. But that's at least that's the background for what we're
for a presentation that was put together in sort of 2 minutes before the request. That's pretty detailed. Yeah, no, that's great. Thank you, Kevin. I guess Bobby,
Kevin,
did you want to?
Kevin, we had very low expectations after throwing you in the deep end. So you exceeded them very much. So
Wait, what happened to Kash? Why is he nice all of a sudden?
I know, man. It's the new cash. Okay.
I see.
It's okay, Boppy. He'll be not nice to me later.
Okay. Hey, Kevin, there are two things. One directly related to Kevin and one not. My impression is the link layer is going to be incredibly interesting with this. And that I'm assuming that, or I'm assuming you want to build a link layer as well on top of this, or changing the file.
So that's a great question. So I think yes is the first answer, and I think probably yes is the second answer. I'm not a link layer expert, and in fact, I haven't attended a single Bo link layer meeting. So we're in the middle of tape out, so I'm not going to get any bandwidth from the digital team for a while. But I do think that that's something we would want to pursue. I view those as kind of, I mean, they're related, but they can proceed independently. The phi part is the part I was hoping to talk about first, but I really don't know how you guys proceed with proposals. So I'm open
Yeah.
to
At
suggestions.
least,
Yeah, I mean, maybe. Sorry, Poppy, you want me to? Should I jump in, or you want to keep going?
no, go for it, please.
Yeah, I think, at least in my thinking, and I chatted a little bit with a few other folks, because I think standardizing sort of the way in which you do a memory chiplet interface, I think is a really great idea. I do think they actually turn out to be related for sort of the following reason. So basically, I believe what this would end up implying is that we would basically be saying that AXI, I assume, by the way, we could do something else, but AXI is probably the default, sort of on-die bus that you would reflect this
Yes.
back to.
Yes, please.
And so if it's AXI, then that does mean there's some set of options and blah blah in the bus that we just have to sort of come to a decision on what they mean. But once we've done that, I think it does influence the phi in that, because it's now AXI and not necessarily the raw DRAM interface itself.
Right.
There will actually be bidirectional traffic going there. And so I think, so then the sort of configurable bidirectional thing gets a little bit trickier. Having said that, what I do think is perhaps an interesting compromise, and in some senses makes life even easier from the perspective of just getting a first thing out. It is certainly the case that the bandwidth tends to be fairly asymmetric between read and write. You typically get about 2x more reads than you do writes. So I think a fairly potential practical and immediate thing we could do would just be to say, okay, yeah, for UMI, here's the particular AXI bus, sort of interface profile and bus protocol variants that one needs to support. But basically in the phi, you statically provision essentially 2x the receivers as you do on the transmitters on the sort of SoC chiplet side, and obviously the other way around on the memory chiplet side. Just to basically sort of exploit that. Obviously there's going to be usage scenarios where that maybe is not the best idea. So that's where I think then some of these additional, honestly, maybe even actually just configurable directionality sort of helps you, and or sort of the dynamic one. But yeah, that was kind of the thinking that I wanted to share, and see what people thought. Did I go too fast, by the way? I can
Well,
I have some related questions, but I'll let the people answer Elad's question, and then I can probably ask mine.
Go ahead.
Wait, just before we, sorry, before we beat Kevin to death on this, Kevin, maybe the way for us to think of this meeting is to simply figure out what the scope of this effort will be, more than actually come up with answers. And then the scope is sort of a good structure for the presentation to the larger group on Friday, or excuse me, to a different group on Friday. So I think my main question is, I'm hoping that the link layer is in the scope, even if it's not going to be addressed instantly, and then to sort of along Elad's questions and a couple of others that I've heard as well. Does that make sense?
The only comment I would have is what Elad said actually makes sense, to have it look at the actual traffic and look at the actual traffic. So if there's obviously more reads than writes, which is logical when you go to memory, right? So you reflect that in the architecture. So it
Amar,
certainly
what
makes
did you do to
sense.
Kash, man?
I'm data driven, Bapi. If the data says X, then you go X, right? So that's the
Yeah.
new cache, whatever the data says.
So I would actually say something opposite to cache
Not for the first time.
to change the mood a bit, you know. But I guess I understand, Ilan. I mean, I think for our use case, that actually is a very good scenario. But the thing I see a little bit different in memory, and I see the benefit of the proposal is that maybe the ratio of read or write might be different in different use cases, and it's sort of a little bit harder to expect the user to know how to set it up before the operation is started. So that might be one challenge in having like a fixed thing configured in the beginning rather than let it go.
Totally.
But on the other hand, it is more efficient when you're not switching from read and write constantly across the pins. So I guess the question goes down the question really becomes in terms of optimization of this, how optimized the solution is that whether these inefficiency between switching read and write for the memory, does that outweigh the certainty on the ratio of read and writes to set up from the beginning? I don't know if I made myself.
These are all great questions and sort of precisely the thread that sort of led down to some of the comments I was making. And at the risk of sort of doing the opposite of what Bapi was suggesting, which is fine. Strategically, I think, basically strategically, I think we can potentially proceed on this by basically saying, look, let's just take effectively Bo 2.0 and sort of link layer, largely speaking, out of the box, come up with sort of what we think the right quote unquote static provisioning is. And from just executing a spec around that, it's very easy, right? Because we don't really have to invent anything new per se, arguably maybe just the AXI interface profile or set of profiles, but there's sort of a very, let's say direct path that you can take to get there. And it really doesn't have a whole lot of technical barriers and things like that to do it. But in parallel with that, I do think that, there are going to be scenarios where, as you're describing, right, you want that extra capability. And I think the sort of the work we could do there could be in some senses two-staged of, one saying, okay, hey, like, here are the range of configurations one may want to support via, sort of configurable bidirectionality, which, as you said, you'd have to know a priori that that's what you want to do. And that will have some limitations. But then B, go ahead and actually develop the true dynamic bidirectionality part of the spec, just to give people the further flexibility and sort of, I hesitate to come up with a naming or whatever, but this sort of gives you even a sequence of generations of things where you have sort of your UMI 1.0, your UMI whatever we want to call it 1.0 plus, and UMI maybe 1.0 plus plus. But I think it does give us a sort of nice staged approach to hit sort of all the different trade-off points that I agree that they all absolutely exist, and I think there's a path to sort of address all of them.
How about the use cases, sort of just putting on the table some use cases early on, because that also depends on the use case, memory type, HBM, LPDDR, etc. Wouldn't that make sense to sort of look at some use cases?
Great question. I mean, I think it's a great idea for us to sort of, in some senses, you're going to end up wanting to standardize, let's say, the width of the thing, quote unquote, right? Meaning like, okay, hey, if you're, here's sort of like what a unit element would look like in terms of the AXI bus it interfaces with and how many die-to-die slices you use, and, how you'd sort of expand that for, multiple channels of HBM or all of those, I think are indeed, great points. And yes, I think it's a great idea to sort of take, okay, hey, if you have, this style of memory with, sort of this type of application, here's the typical numbers you'll see. And here's how that would map onto the, whatever it is we decide or the way we partition these things.
So wait, if if we take the purpose of this meeting is to not solve problems, but to provide scope to Kevin, then one is the obvious, the five thing that you've started on. The second is maybe the link layer discussion. And the third I'm hearing is the idea of also explicitly calling out the different types of memory to be supported, right? That's what I'm hearing. Is that fair?
Yeah, and also, yeah, also
not-
the use case, sorry, sort of end system. I mean, it's a bit, you want to be flexible, but some examples of use case, for example, if truly HBM in standard package, how does it come, etc. It would be good to have some system or solution use case as well in mind, and prioritize it so that then when you talk about memory, it makes sense, types make sense. But maybe I am not the expert in this area, but I always like
do you mean the physical packaging, or do you mean the
no, I
logical flow?
what problems does it solve?
Yeah, I mean, that's certainly something we could discuss. I mean, we've definitely promoted standard package HBM at JEDEC, and PHY, guided PHY that can support that would be of interest. And that could be gives you roughly how much bandwidth and in how much area or beachfront is needed. So those kind of things could be put forward as problem scopes that you could look at for solution space. So that's doable.
Right,
Fantastic.
and also support some benefits, because it's going to come at some cost, and you want to always qualify it. And then use cases and memory types helps make a case for it. I'm sure you've made your this is your business, but sharing it in both would be useful.
Yep.
Wait, are we going to grade success, or are we going to grade the quality of any proposal based on the use case? I'm asking, not recommending.
I mean, there's no reason not to evaluate things, I suppose, right? Like, I mean, as usual, right? There's going to be a little bit of I want to call it research, but yeah, I mean, there's some data that needs to be gathered, and just say, okay, look, if we take the following approach, here's what that will imply, and here's that maps, here's how that it looks relative to various use cases. So I can't, to the extent that somebody, folks are willing to do the work, I can't see any reason. I think that's great work to do.
I have a quick question on the bidirectional PHY. So when we are saying bidirectional, so today we have 16 TX and 16 RX. So is the proposal to make that as 32 bidirectional pads, or are we still going to use them in a static configuration? But then now, since the pads are supporting bidirectional, we can program any pad to do a TX only and any pad to do an RX only. So I'm trying to understand what is the proposal here.
Yeah, I believe, and Kevin, correct me if I'm wrong, but I believe the mainline proposal at the moment was basically much like a DDR PHY, where the entire slice is turned around one direction or the other. So not necessarily at finer granularity than that, just over time, or dynamically in time, one can either be using a slice as a transmitter or as a receiver.
Got it. So then my follow-on question to that is, I mean, if we do that, then I'm assuming, like, keeping apples to apples comparison. Now we have 32 bidirectional PHY lanes instead of 16 TX and 16 RX. So, but then since each lane now
So
has
yeah, just to be careful, you can still leave it as 16. Yeah, you can still leave it as 16, meaning that there's 16 bumps and there's 16 transmitters connected to each bump on one side. There's also 16 receivers connected to one bump on each side, and there's the symmetric structure on the other side.
Okay, so if we do that, then we are basically cutting the bandwidth in half. If we that's why I wanted to keep it as apples to apples comparison. But fine, if you are doing it that way, then we are cutting the bandwidth in half. But if you are going to 32, my point was basically we are doubling the size. So yeah, I mean, bidirectional pads come with its own cost, is where I was getting at.
Yeah, so just to be careful, I think ignoring turnaround overheads, which are a real thing, and so obviously, can't be ignored entirely, but ignoring them for a moment, I think if you define bandwidth as, in either direction, I think in principle, it doesn't necessarily change the bandwidth per se. But certainly from a circuit area and obviously, as we said, the bus turnaround, that yes, those are the overheads you end up paying.
I don't necessarily agree on that, right? Because
So
say,
Rob,
sorry,
let
go
me
ahead.
try to explain then. If you very simply, that's first of all, you don't have to, but if you're using bidirectional PHYs anyways, in a configurable bidirectional sense, then you already have receivers and transmitters at every bump. Let's just start with that as an assumption, okay? So if you want to configure to have, 16 bandwidth of 16 in the transmit way and 16 in the receive way, you need 32 bumps, and that's your beachfront. If you use them in a dynamic bidirectional manner, you can get the same bandwidth modulo the turnaround time that you mentioned out of just 16 bumps. So you actually cut the beachfront in half. And that's why bidirectional PHYs are used everywhere in memory. So there are many, many different variants that we could pursue, but at a high level, you can cut the beachfront in half to keep the same bandwidth. Does that make sense?
Not necessarily, right, Kevin? Because say your application relies on bidirectional traffic all the time. Then in that case, having just 16 bumps and switching the direction every time there is something to transmit on either side, you're at least cutting the bandwidth by half, because now in the previous case or in the existing BAU spec, the way the spec is defined, you have 16 dedicated TX pads bumps and 16 dedicated RX bumps. So assuming that you're running at say 8 gig per second, you have an aggregated bandwidth of 16 gigabits, right? I mean 16 Gbps, right? So, but then if you're going to now compress that into just 8 dedicated pads, aren't you not cutting the aggregate bandwidth in half?
Yeah.
Because now every time either side needs to wait. I mean, either side can transmit or receive every alternate cycle now. So you're basically cutting your bandwidth.
Right, but
bandwidth in
the
half.
memory core can only read or write. It can't do both. So memory buses are always bidirectional for that reason.
Right. I mean, yeah, this may probably apply for memories. Yes.
But that's what we're talking about is memory. So what you're saying is you could dedicate 16 pins for transmit, 16 for receive. Totally agree with you about the total aggregate bandwidth there. It's just you can't use them. Half the time you're not using those transmits because you've partitioned more bandwidth than you can actually consume in the device. And if you look at proposals for memory interface proposals using die-to-die links, that's what they do. They over provision because they really don't have a choice. To the extent you can power off and you don't waste too much power on the write path while you're reading, it's not terrible, but it just wastes a lot of pins. So I just think that there's a space here of things we could pursue here, though, and I think Elad, you brought up we could just fix 2x the transmit versus the receive. FB DIMMs, some memories do that. There are use cases that want to have a lot of write bandwidth, like when you're initially filling up a table and stuff.
Hey, but wait, so
there might be
we're down to 20 minutes, and I want to make sure before we solve the problem, at least that we're agreed on this. You have the scope, right, Kevin? At least as far as
I think so, but I think what Eli brought up as a scope is standardizing memory chiplet, using a die-to-die, which could have, in his words, first, take the Bode 2.0 and the link layer out of the box and arrange it with an axis profile with probably 2-to-1, and then second, look at adding true dynamic bidirectional. So the scope is going to be possibly more than one solution under this umbrella of memory chiplets. Is that Elad and Bapi? Do you both agree that's kind of
Roughly
what
speaking, yeah. I mean, and I think just maybe to further clarify, my thinking there was that it's sort of like that the dynamic bidirectional would sort of be like an add-on mode that people could sort of do transparently, quote unquote. Obviously as long as you have that functionality included. And at least at the moment, I don't see a reason that can't be done. Obviously, it's not not actually engineered, and so there may be thorns in the bush there. But that was sort of my thinking. So in other words, I didn't intend for it to be sort of a bifurcation per se, but more in there's the default thing that sort of everybody does, and then there's the more advanced version that people can add on top of it.
Okay. Yeah.
Well, it is not yet clear that, and maybe that the link layer as currently defined is also suitable for use in this application. And I think we'd have to figure that out too.
Right. We have to figure that out.
So in some sense, I think there's what the sort of the system level problems you're trying to solve, how many different distinct kinds of memories you're trying to support, whether the link layer as defined is suitable for you or you need changes for that, and then finally the specific 5 changes that you already have in mind are the 4 things in scope as I understand it, maybe.
Sure, but actually, can you say that again? I'm trying to capture it so I can make sure that I get it written. So you said the 4 things in scope were
The 4 things that I heard today, or 3 things I heard today, is that one is the system level, at least 1 or 2 system level use cases against which this proposal has to satisfy. But I think the one I heard from Ramin constantly is more HBM within a package. The second is a link layer to go along with any proposed changes on the file, and whether the question is whether we can use the link layer as it's currently defined. And if we do, then the point that Elad made, which is what kind of profiles into AXI. I mean, there's a whole bunch of second order questions that pop out once you say we need to use a link layer. And the third is
just maybe to quickly follow up on that, I do think that it isn't right. If we are defining this as the memory chiplet interface, then that is the type of traffic profile you see sort of on the AXI side of it is definitely different than what you see on the raw memory side. So that's that is important.
Correct, but that's just what we're calling the interface profile. I'm not even convinced that the raw link layer itself is viable.
Why?
Oh, okay. Again, I'm going to violate my own rule of solution. So let's just assume like at least it's worth checking out, basically. It's worth checking out that we can satisfy.
I can tell you we've delivered AXI, AXI bus things, that happen to be talking to memories, a lot more than once based on the ODSA spec.
Okay, as long as we can satisfy the latency requirement, round trip latency requirements, I'm okay. At least we have some viable proof positive that we can.
I think the trick there is that if somebody has decided to do the memory has decided to chipletize the memory interface, then that they've bitten that bullet already. Is I guess the way I would say it.
So that's 2, and the 3 is the actual 5 changes that were the 5 changes and the range of packaging technologies for which those 5 changes are relevant.
Okay, and so at a high level, my understanding is the sort of overall this proposal discussion with these 3 elements takes place in the Friday meeting. The 5 discussions would take place here, and the link layer would be in the Thursday meeting. Is that
roughly? But we're sort of beginning to merge into, yes. I mean, the Friday meeting is not a regular thing. It's more simply to make anybody aware, look, we're starting this new thing. If you're interested, come on in. That's about it.
Right. Yeah, the scope part is more.
Yeah,
it is not an ongoing thing, but the fine link layers could be ongoing meetings.
Yes, they are ongoing meetings.
Okay.
Bapi, I have to run in a minute, but I did want to just suggest that, if there's any way to invite some memory guys into the discussion, either for this Friday or some other time, that would be great. Right,
yep, that's a great point. So what I will do is send it out to a bunch of people and say, hey, we're going to do this. And I'm assuming Elad can do the same thing. All of you everybody here can do that. And so, if we have some notice on about a week's notice, we can round up an audience for that.
Yeah, I think you and Ramin said you were targeting a week from Friday to have the discussion, right?
Yes, so it's your call. I either yeah. So if you're ready on the 3rd, that'll be perfect.
Yeah, the 3rd's no problem.
All right.
And we need time to get people there, so this Friday might be a little tight.
This Friday will be a little tight, but if we can do an abstract, then what we can do is, Elad, I'm assuming you know some memory guys and anybody else here too, not just me, Marek, or all of us can sort of round up whoever we think, and Majid can round up whoever we think should be here. And obviously you as well, Kevin, whoever you want to invite to this.
Okay, sounds good.
Yeah, just not that that's as a total side note, I might not be able to join next Friday, but you know that shouldn't stop anything.
Can you join on the 10th? Or do you, maybe we shouldn't put it out there. Okay, you know what's going on anyway, so yeah. Okay.
No, the 10th is actually somewhat better, but anyways, yeah.
Well, Kevin, do you want to wait until Elad's here, or you can decide. You can either go on the 3rd or the 10th. You can decide offline.
Okay.
And Elad, maybe send your friends or something on the 3rd if you can't make it.
Yeah, no. If it's like I said, don't get on me, obviously.
Okay. So there is one other question I have before we, in the last 10 minutes. Are we going to make changes? So whenever we made bow modes, we said there have to be something that supports this mode has to be compatible with all the other modes. Are we going to make that restriction? Like, is that going to stick? Are we going to make a bow derived file or a bow mode?
I think, how should I say this? I think dynamic bidirectional would have to be yeah, like you said, we've never really defined this term very carefully, but it'd have to be something that, you know, both sides actually can support it, and if they can't, then you don't do it, right? So in your categorization, I'm not sure exactly where that one falls, but you know, the assumption is that if somebody can do dynamic bidirectional, they should certainly be able to do static bidirectional or static direction. So I think it's quote unquote easy in terms of the interop there.
But do we also want to support like all the other things that you got to support, you know, 2 gig, 4 gig, 16 gig, 32? I mean, do we like, what kind of obligations do you want to place on it, that it has to be a bow file that is backward compatible with all the other operating modes? I'm asking, and not.
I see. I mean, I guess, why don't we do it this way? Like, let's start for the moment assuming that it has, you know, whatever the same requirements placed on it as the other ones do, and then, you know, as soon as we find something where that breaks, we can obviously revisit.
Because we ran into this with Kash too, right, last week.
Sorry, one other thing that I want to put on the table early that is part of this discussion is memory doesn't like to be constrained to by 16 elements. There's always ECC. The natural element for memory files is by 18, and there may be complexities like that make it much more of a bow derived file than a I don't remember the other phrase you used.
Yeah, no, it's fine. I think this is again where the key thing of, is this data die actually carrying, is this data die effectively acting as the memory file, or is it really just carrying AXI? Because I think you get sort of a very different answer in those two cases.
Yeah, you do, absolutely. And it really all depends on where the memory controller is. The memory controller
that's a really good question, Kevin.
And you're connected
that question is worth answering, at least in the scope.
Okay.
Right. So yeah. So and I think, Kevin, you hit the nail on the head. Is, you know, which side is the memory controller actually on, right? You know, so I guess said differently, are you carrying AXI or are you carrying DFI in some senses?
Some sense, yeah. And if you talk to a memory guy, they want to carry DFI and want to be responsible for the memory controller. So.
Oh, interesting.
Yeah, I think
that's
too.
That's really interesting, because that also means that, you know, that basically sort of you then lose the flexibility of which memory type you're actually putting on the other side, right?
I know. Yeah. So if it's a memory chiplet that then has a memory PHY that then talks to memory, then it's pure AXI. So you know, and then it can carry simultaneous read and write traffic because there's bubbles between it and the actual memory interface. So it's a complex world. So we need to, like was early brought out, just talk about some use cases and make sure that we know.
So just to clarify, in the case where you're carrying DFI, the thought is that there's still a memory chiplet somewhere, because like I assume that the data DiFi is not literally talking to the DRM IOs, right? Like it's still sort of, just talking to another quote unquote SOC or logic process thing that is then talking to the memory PHY, or not necessarily.
I mean, in most of the cases we're looking at it is, but I'm not sure I can say exclusively. And HBM is the one that's tricky because the chiplet is really a base die that's below.
Right. Right.
So and it historically doesn't have any controllers or logic.
Yep. No, it makes sense. Yeah, no, there's yeah, there's a few different options in that space. I totally see what you're saying.
So maybe this is the zeroth order thing to resolve, where you're drawing that line, at least for your proposal, not necessarily for everybody on planet Earth.
Yeah, well, I mean, just to throw out a thought, and again, I'm gonna somewhat blatantly ignore the don't talk about the solution. Yeah, I mean, it seems like what we potentially could do is define sort of the, hey, you're talking to a memory chiplet version, just again because it's kind of the low-hanging fruit from a what needs to be developed perspective. Arguably even develop the version of that sort of has the configurable directionality kind of stuff. But perhaps, and this is where the devil, the details will really be, perhaps that, sort of dynamic, but, directionality piece, along with doing that, it can also sort of encompass or fold in the mode where you're really talking, sort of maybe not literally, but much more closely to the actual DRAM IOs. Yeah, that's all of that can certainly be, anyways, that may be a strategic way to do it. And if it turns out that, the version that you're talking to the DRM IOs is just different, we would have had to do something different anyways. So, so I don't think we've necessarily lost anything from that standpoint.
Okay.
So what does that mean in plain English then? So,
what it means in plain English is that, that you don't necessarily have to do a selection between the two, right? We can define the version that, is AXI plus, die, and is presumably with the memory controller on the other chiplet, whether that other chiplet is a base die or an explicit chiplet, just, whatever that happens to be. But, let's say architecturally you're carrying AXI stuff, and that has its own set of implications. And you can do that in parallel with defining and, exploring further the mode where, you're actually carrying DFI and figuring out, sort of what the implications of that would really be.
Okay, so then this would be part of the scope that we would have to recognize in kicking this off, that there are these two potential ways you can slice this.
Yeah.
And I think what I'm sort of indirectly proposing is we just say, we're going to look at both. Yeah, that's basically what I'm saying.
We're going to look at both, but we recognize that there are two.
We recognize it too. But I
Right.
do think it's back to what Elon said originally of first, it's first going to be as an AXI, and the second is true bidirectionality around something like DFI. And
Yep.
so I'll try to write up a scope that encompasses both, Poppy,
Great.
and we'll talk about
Awesome.
it. So I know you're talking about the 3rd and the 10th, but can we talk more this Friday?
This Friday, we have somebody from UCLA who might eat up a chunk of the time on chiplet cost models.
Okay.
We could talk about it tomorrow at 9 a.m. if you'd like.
I don't know what's tomorrow at 9 a.m.
The link layer meeting. So we could just use that for this.
I see.
If you want to continue the scope discussion, we could do it there.
Okay.
Since we have 3 minutes, one quick sort of clarifying question,
Doesn't-
and I know
Doesn't work
introduced
for
the
me. Yeah, it doesn't work for me, but yeah, okay, it's okay tomorrow.
We don't need you, Majid.
I know I'm not contributing anything anyway.
No, man.
Thanks.
No, now that I met you, I feel comfortable insulting you. That's all.
Exactly. I love that. I just that's a club you could join only if you had, if Bappy can throw things at you.
Yeah. So, no, if you can send it, but it's a scope. We'll continue the scope discussion. If you want to send somebody from Can-Do or
No, it's okay. It's okay. I'll
Um,
juggle.
But yeah, Kevin, if you want to, we can blow some chunk of tomorrow's meeting.
Okay, I just put it on my calendar. I can call in and I will, I'm not sure how much more I'll be prepared in 24 hours, but I'll do my best.
No, that's
No,
fine.
no worries.
That's fine. We'll just have it on. This is good. You can be the exact same bridge. It's good that we use the same bridge now for every meeting.
But by the way, I noticed the meeting you scheduled on the 31st, you used like a Google Meets, some kind of weird.
Oh yeah, that was a placeholder. We're going to use this bridge again, but I
Gonna
did.
use this.
Yeah,
Okay.
we're going to use the exact same bridge.
Okay, thanks.
Yeah, so sorry, just I was gonna ask one quick clarifying question, and I know I introduced the terminology. So I guess, Kevin, is there a thought of literally carrying DFI, or is it really much more, you're almost, for all intents and purposes, really talking to the DRMIOs? Or both?
It's not literally carrying DFI.
Okay.
So UMI as envisioned was packetized. It's not straight AXI and it's not straight DFI.
I guess maybe I should ask it a different way. So like the interface into the data subsystem would be some customized thing that is not quite DFI, or yeah, is that's what you're implying?
That's what I'm implying, because of the way you're just trying to maximize or minimize the number of pins and get the best utilization of the beachfront. So
Yep. No, it makes sense. Yeah, I mean that makes sense. I mean, I guess
has complexities, and they, as we're saying in this meeting, they do relate to the PHI.
right. No, I mean there are. Anyways, we should definitely. This is probably worthwhile, good discussion for tomorrow. There are some things in, there are some ways about there's some things about the way the link layer is built currently that might actually make real DFI not as bad as it first sounds. But anyways, that's a separate discussion.
Okay. As I mentioned when I chatted with you last Monday, I have not read the link layer spec. I'm not familiar.
Yeah, no worries. Yeah, it's a great it's a prefetch for tomorrow.
We tell them the great news is no one has. Not kidding.
It's not I'm a PHI guy, as Elon knows.
Yep. No, this is awesome. I'm glad. I thought it was a crazy idea when Elon suggested it, but I'm glad we had this discussion. On
Thanks
the
for
scope.
springing it on me, Elon. So that's great.
Sorry.
I said thanks for springing it on me, Elon. But
I know that
Anytime.
now he'll be.
anytime.
It gets worse when we encourage him. All right.
Okay.
All right.
Great.
Thank you. See you.
Thanks so much,
tomorrow.
everybody.
Thanks,
JP's here, and it's his meeting from 10 o'clock. Thank you.
Thanks. Bye.
Thank you. Bye bye.
Bye.
Hey, JP, that's great news on the publication. Now we just have to get Ishan to present at some point.
Right. Yeah. Bobby, do you hear me?
I can hear you.
Okay, great. I'm just driving, so I just want to make sure. Yeah, it's a great news that he could publish it, publishing it. He's been actually busy with his thesis submission or something. But did he get back to you, Bobby, on the date?
No, not that I know of.
Okay. Okay, I can ping him, but he said he's something with the thesis is working on. Yeah, I don't know if you got to see the final version of the paper. Did you see it, Bobby?
Nope.
I will get that to you. Yeah, kind of a lot of people. So it's good OCP effort. Like that has a large Facebook team and everybody. So it's a good one.
Hey, TJ. Hey, guys.
Hi. Sorry, I'm may I know who is speaking.
I think that was just some background noise on my side. Hey, Boppy, hi, JP. Hi, Tarun. This is Trent.
Oh, hi, Trent. Sorry, I missed you. How are you doing?
I'm doing well. How are you?
I am doing good, and you'll have to excuse me today. I'm just driving probably another 15 minutes away from where I can
Oh, okay.
talk. I don't know if Tarun is there. I want to talk to him. You got the document that he sent out, right? Trent?
Let's go back over.
Hang on, there's some background noise. The document that Tarun had sent out?
Yes. He actually wrote that spec for our board, bring a board.
It was a couple weeks ago, Trent, I think. So
Oh, Tarun is there. Hi, Tarun.
yeah,
Oh, yeah. Uh-huh.
yeah.
Yeah, I did get it.
Yeah, I have a conflict, so I have to leave a little bit early today. So yeah, I apologize for that.
How much time do you have, Tarun?
I have to leave at 10:15, JP. Like
10 minutes, right? Okay, that should be good enough, Tarun. Actually, what I want to give some updates on the summit, right? And the OCP summit, I met Josh from Facebook, and so he's a mechanical team lead from Facebook team. They actually kind of they didn't exactly say they'll have a resource, but he will have he'll look into getting us a resource, mechanical resource for this project to work with us, right? So we can discuss it. They are very good. We worked with them in the past from ODSA. So let's see if he can get that resource so he can contribute more. He has done similar work in the past. So the Facebook team, so what I'll do is I'll copy you, Trent, and everyone, and Bobby, and send an email request to Josh. He wanted me to send an email request along with what we are trying to do. So you wrote the spec, right? I'll send him that spec and give him some pointers what we are looking for, and then he'll get back to us on getting us the resource. So I don't know if Bobby is still on the call. Bobby, are you in the call?
Yeah,
I'm
Bob
here.
is.
I'm here.
So Bobby, you are still with the plan, right? That's okay with you, correct?
Yeah, so there is one thing I wanted to talk to you about. One of the things I noticed is that Blue Cheetah has their own sort of bring up board, and you guys, D Matrix, have your own you guys have your own bring up board. And how do we make a case that what we're building is something that should be built, even if you have your own bring up board?
No, it's actually, I mean, looked at Blue Cheetah board. I don't know if anyone has joined from Blue Cheetah today. I spoke to Bhaskar, and then there's one more person, I forgot his name, is a VP of engineering there. He said one of them will join the call, the 10 a.m. call. They have a very good board. Blue Cheetah design, I like the board. And Bhaskar designed the board, and he said they can open source their design. They have everything what we're looking for. The power supply design, voltage tuning aspect, software, and everything. So they are very interested in working with us and open sourcing some of their designs. So it'll be good to collaborate with them, and right, maybe what Tarun wrote the spec is a good starting point, and then Bhaskar can add because they already done that. Yes, D Matrix has also done that, but some of them are done by a third-party company. So probably not sure about everything, but Blue Cheetah design is actually it seems to be a good fit for what we want to do, and they will willing to contribute as well. So Bobby, to answer your question, like even see, this is for the current generation, right? The current generation won't change. If they have a board, they won't change it. There's no reason for to get a new board. But what the bring up board, what you're talking about is for next generation. In future, we'll have to start all over building a new board, Blue Cheetah, D Matrix, or any other company. But there was an approach we are proposing that we can actually simplify it and we can share software and everything, right? That's the main.
You're right. No, I get all that. I think we should just make that case that even if you have your own board, you need this is a good idea because and you being in D matrix strengthens that case.
Yeah, exactly, exactly. I mean, if you have like this, we would adopt it actually.
Yeah, that
So next,
but actually making that argument is a good thing in my head.
sure, yeah. I can make the case because we would adopt it.
Yep.
Um,
Yeah.
Yeah. So and the other, yeah, blue chair. Let's see. I'll send an email to Bhaskar, because actually, I don't know if you invite him to these calls. Right. I think we should and yeah, this is what I want to mention that the Blue Cheetah board has the same FPGA that what you want, the Arctic 7 FPGA that we are trying to use on our board. So they're using the same FPGA, so it makes it a lot easier as well. So I think the next step is to merge all these efforts, what we are doing, what Blue Cheetah has done, and what D-Matrix, some of it what I've done, merge all the efforts and put together a strong spec along with the Facebook. If we get the mechanical resource, then we can put together an effective proposal, what we want to do before we go to all the other companies that we talked about. What do you think, Bobby?
Makes sense, JP. I think that's exactly we got to the next month in the before in Q4 is when we have to make this thing swing or sing rather. Excuse me.
Right. Yeah. So what I'll do is I'll send an email to Josh and start with that, and also send an email to Bhaskar, and then we'll go from there. And the 5 minutes we have now, Tarun, can you actually give a kind of overview, share your document, give an overview of what you think you covered in your document?
Sure, JP. It's just like couple things. Let me try and find that. Hold on, sorry.
Yeah.
Okay, just one more minute. All right, can you guys try to share my screen? Can you guys see my screen?
Yes.
Okay. Yeah. I mean, I kind of did it in a suggestion mode. Let me actually just go ahead and accept the suggestions. I think it's just language. It's nothing. Oops. Let's see. Okay. Okay, so basically just the introduction is talking about the purpose of this board, right? So it's like basically we are trying to develop a board and then make sure it's like open source, both hardware and software. So like JP mentioned, it's for future versions where folks don't need to develop any new hardware. They can just they can use this infrastructure to develop their hardware or like rather test their chips, which has like a BOW, so the main thing I've given like I've written like the architecture and so this is like a small a block diagram which I mentioned. So we have like a motherboard, a DUT board, FPGA mezzanine board, and then Raspberry Pi controls. So or we can have a different CPU to control the FPGA board. So what we are proposing is having like a bunch of LDOs, and everything can be programmed by either Raspberry Pi or FPGA. And then FPGA is a good idea because like FPGA has like IO banks where we can adjust the voltage, program the voltages through which we can communicate to the DUT board. So some boards may have like 1.8 or like 0.8 or whatever. So these voltages can be changed at the IO bank, and that's one of the main advantage of using an FPGA board. And then I've just talked a little bit about the daughter card. So LVL, we already have like a board like an FPGA mezzanine board which can do everything. So the development for this whole and I think it's called the Cryo Captain board, and then I think folks have like agreed to make it open source. So I think it's like the development of the whole thing will be extremely simple. You just design the motherboard for this FPGA board, and then you just plug in this board and plug in the Raspberry Pi, and everything else is software at this point. That is what I've basically mentioned here. The FPGA, and I've given a little bit information about that, the FPGA daughter card. So bottom line is, it's like we just have like an motherboard and already developed FPGA board. So it's like the development of this system is going to be extremely simple. Raspberry Pi, we can buy it off shelf, and then essentially we can buy this board off the shelf, and then it's just communication and then controls. So it's going to be an extremely simple board. That's the bottom line.
Okay, thank you, Tarun. So, Tarun, did you also include the physical information? How does it look like? We have a picture, right? Do you want to include that?
I still don't have the picture, JP. I'll add the picture today. My colleague who has the board. Yeah.
But if you can add it, that'd be great.
Yeah, I will add it. I'll add it today. See, my colleague who has the board, like he was on vacation for the past week. I think he's back this week, so I'll just grab a picture from him.
Sure, yeah.
Yeah. Is also Boppy. This is the same board which I showed you when you visited LBL a couple months ago.
Oh, perfect, man.
Yeah.
Perfect.
Yeah, I think then this will be a good start. Then once you update it, I'll send this to Josh, and we'll request a mechanical resource with this. And that'll kick things off.
Sounds good. I'll add the pictures sometime today, and I'll just send you an email to JP so that like it's added.
Okay, perfect.
This is good. This is a good idea, Tarun.
Yeah. Anything else, friend Bobby? I think that's all I have from an agenda standpoint.
Okay.
Bobby, do you have anything further interest on what we are doing from the summit?
No. The summit turned out to be way busier than I thought it would be.
Right.
The summit is been. Anyway, we'll get cracking on this. I think we're beginning to get some specific way forward, and we'll get cracking on this.
Okay.
And I like Ishan's paper. I like that too. So.
Okay. Sounds good, Bobby. Okay, thank you then.
Thank you.
Say, JP, this is Trent, quick question. So this person, George, that may be able to help out with mechanical design, that'll be for the thermal mechanical design of the board and the system. And then we would still need to have the boards built, the system built somewhere, right? Or would George also?
Yeah, exactly. But they, Facebook team would only do the mechanical design. They will not fabricate.
Okay.
Right. Yeah.
All right.
Still, I mean, let us know how your team can help. We already discussed some of it, but I think it'll be good to have more people join as per some of the stuff.
Yeah, because if if somebody else does the mechanical design and then we just end up needing to fabricate it, perhaps our team here can still help, procure everything and have it fabricated. And I think that the price would be a lot different. And then, of course, then we need to talk about the bring up and testing of it, right? Who could do that, because
Right.
okay, so we'll have to have some discussion about that after I guess
Yeah,
we engage with George and see what he can do.
Right.
Because there's really a couple ways, with if the mechanical design is done, and then it's just a matter of fabricating and putting the systems together, and actually having them built. And in that case, if we're passing the hat, and even from the NXP standpoint, if I could kick in also, and then we just find a fabricator that can do it, or we could see. I think that there's still an opportunity for our board team to support it, and probably come in.
I'm sure.
Come in at a better price, just based on what we can resource.
Correct. Yeah.
Okay,
Yeah,
great.
thank you. Okay, thank you. And Tarun, let's catch up next week.
Hey, thanks for hanging in there, guys. We'll now the summit's over and everything's over, we will put renewed energy in this.
Thank you, Bobby. Absolutely.
Thanks.
All right, great. Thanks.
Bye.
Bye-bye.
Yeah, bye.